Hello, my name is Justine Olegario, and on behalf of Swastika Regmi and Dr. Sinan Sousan, I am pleased to share our original research titled Evaluation of Low-Cost Optical Particle Counters for Agricultural Exposure Measurements. Farm workers face occupational exposures, like dust, that lead to respiratory symptoms and disease. The effects of dust exposure are both short and long-term, with long-term effects including the development of asthma, chronic bronchitis, and chronic obstructive pulmonary disease. The Occupational Safety and Health Administration, or OSHA for short, sets standards on occupational exposure limits for air contaminants based on filter-based measurements. The 8-hour time-weighted average exposure limit for particles sized 4 micrometers, or PM4, is 5 milligram per meter cubed. However, studies conducted on environmental and occupational exposures have utilized low-cost aerosol measuring instruments, like optical particle counters, or OPCs for short, to estimate the number of concentration of particles. The mass concentration can then be obtained by assuming the particle shape and density and applying them to the number concentration. For our study, we focused on the evaluation of two low-cost optical particle counters in measuring agricultural exposure to respirable dust size PM4 in swine barns as a cheaper alternative to using filter-based measurements. For our study, we used two OPCs, the OPC N3, which is capable of reporting particles of size 1 micrometer, 2.5 micrometers, 4 micrometers, or 10 micrometers. In other words, it can report PM1, PM2.5, PM4, and PM10. The second device was the AirBeam 2, which reports PM1, PM2.5, and PM10. We also used an SKC AirCheck Touch air sampling pump with an aluminum respirable dust cyclone to establish a cut point of 4 micrometers to compare to the OPC N3. In addition, we used the Grimm Mini-RAS to be the reference instrument in reporting the aerosol size distribution within the swine barn. Filters that were used for the sampling pump were pre-weighed and assembled into filter cassettes and were labeled and stored until the day of use. All equipment was then divided into two sets and color-coded. One set recorded area measurements within the swine barn, and the second set recorded the farmer's personal exposure. The experiment took place over 5 days, and measurements were taken during the farmer's workday. All data was downloaded from the devices upon arrival to the laboratory, and filters were stored for at least 1 week before being post-weighed. Now let's look at some results. Here we have two plots. On the left is one plot showing a comparison of the respirable matter for personal measurements between the OPC N3 and the mass concentrations of the filter measurements. The marked X in this plot denotes the average OPC N3 measurement. We see here that the days where the OPC N3 average concentration was 40 microgram per meter cube or lower, the OPC N3 was in closer agreement to the filter measurements. On the right is a box and whisker plot depicting the comparison of personal measurements for PM2.5 between the OPC N3 and the AirBeam 2. The OPC N3 are the darker boxes, and the AirBeam 2 measurements are the lighter boxes. For PM2.5, we see that the AirBeam 2 is greatly underestimating the concentration levels of PM2.5 that the farmer was exposed to. Not pictured here is the aerosol size distribution, which was bimodal in shape, with the majority of particles as being coarse particles. In conclusion, the OPC N3 performed better than the AirBeam 2 and may be suitable for occupational settings. The AirBeam 2 showed high variability and vastly over or underestimated exposure levels depending on which particulate matter was being reported. Therefore, the AirBeam 2 may be better suited for environmental measurements. And because the particulate matter was mostly coarse particles, in other words, size 2.5 micrometer or greater, farmers should continue to wear N95 respirators when working in swine barns. Thank you again for allowing me to share our research with you.